Okay, let's begin. So today we are looking at sample type number 3, projectiles launched off the edge of a cliff. And the only real difference here is that there is a overall vertical displacement, and the time up is not anywhere near the time down because, well, the distance down is a whole lot more than the distance up, right? That's really the only difference. So projectiles launched off the edge of a cliff. There's an old computer game called Gorillas, where they had gorillas on random heights, and they threw flaming bananas at each other. You had to actually, so the math involved was actually exactly that simple. How they was going to do it sucks. Flaming bananas at each other, yeah.
Are you going to pull it up and show us the game?
Maybe. Okay, so here's a sample question. I'll let you copy that out. I probably should have this done, to hand the kids. The ball is hit at 53.1 degrees above the horizon. There's a reason why I picked that number. You'll see shortly. Has an initial velocity of 10 meters per second. Those are the things we're going to find. You don't necessarily have to do all the find because I'm going to do them like step by step, right? So you probably don't need to copy that. Okay, let's begin. So the first thing that I've asked you to find is VV and VH, vertical and horizontal. And I think I actually have to write these out. Oh, I can't believe I have to do this. V sine theta. So it's going to be 10 times sine of 53.1, right? 10, 8? 7.99 maybe, 8 meters per second. That's why the 53.1. And then VH, the horizontal component. Yeah, cos 10 cos 53.1, and I think it's 6, am I right? 6 meters per second. So that's why that number was picked, so that those are nice integer values. Now, you can't tell me that there's no one in the room that can't do those. So there's 2 marks guaranteed. Right? I think it's 11. Are we good there? Yeah? All you're doing there is finding the x and y components, right? Of the velocity. Okay, next thing to find is the time of rise. I get up around 7 o'clock this morning. Little jokes, yeah. Well, because I usually get up around 6, but I stayed up late to watch the Cubs. So. Okay, time of rise. So we are talking about that point right there, right? What special thing is happening at the peak? The velocity becomes 0. The vertical component, right? The vertical component becomes 0. In fact, the 8 has worked its way down to 0, right? The 8, because that's the vertical component. So we're going to say VF equals VI plus AT. And our vertical component is 0.
Excuse the interruption, but all grade 11 courses.
And we are, the initial is, what was it, 8? Plus minus 9.8 t. And you got to be able to solve this. T is going to be minus 8 all over minus 9.8. Okay, so this value here is going to be what? Yeah. 0.86? 0.8 seconds. This for what? 0.82? Okay. Again, I point out, is this anything new? Not. Height of rise. How high does it go? Well, we know we're solving for the displacement. We know the initial velocity. We know the time. I could use this one. Or now that I don't even need the time. I could have done it this way, right? Either one of those would work. People like this one because it gives you the d value, like it sort of gives it, here you got to solve for, right? But if you don't have to figure out the time, then this one will work just as well, right? Do you care which one I do? This is going to be 8 times 0.82 plus 1/2 of minus 9.8 times 0.82 squared. I finally got my graphic calculator back. Yes. Terminator TI-82. .27 ish meters, right? How did you get that? Concentrate on me here, please. Or if you're going to do it this way, it would be 0 equals 8 squared plus 2 times minus 9.8. Oh, this one's way easier, guys. Is it not? No. Nuh-uh. It's going to be minus 8 squared all over minus 19.6. Right, so minus 64 divided by 19.6. 3.27. Right? Again, nothing new. Ready to go on? Okay. Total time of flight. Here we go. Dan is right. Does the time up equal to the time down? Not even close. Not even close. What is your question, Dan? Well, we know this time up here, right? What was it? 0.8? 0.82 seconds, right? So, and we know this distance now is 3.27. Okay. So we know the 0.82 already. Could we not just figure out the time for it to fall 403.27 meters and then add those two times together? Would that work? Okay, let's do that. Can I delete this big picture?
Are we going to minus the 3.27?
No, we're going to add it because it's going, right? It's going to fall 403, right? Okay, so we're going to say that the total displacement now is 403.27. In fact, it's actually not positive, it's actually negative because it's going to fall, right? Hannah's looking at me. Because the cliff is 400 meters and it rises 3.27, right? So it falls 403. Okay, so D equals VIT plus 1/2 AT squared minus 403.27. Now, what is the initial velocity here? Is it 0? 10? What is the vertical component right there? 0, right? So minus 403.27 is equal to minus 4.9 t squared. So t is going to be the square root of 403.27 all over 4.9. I guess technically it's negative and negative. Get 9.07 seconds, roughly? So that means that the total time, I'll go little t, big T, total time, or time total, would be 9.07 plus, what was it, 0.82? 9.89 seconds. That's not that bad, is it? Now I want to show you an alternate way, just to give you some experience here. To do it this way, I needed to figure out that 403, right? I had to come up with the 3.27 and I had to come up with the 0.82. So I had to actually do this step and this step, right? Is there a way that I could have done it all right from here without going through these things here? And I alluded to this yesterday. I'm going to insert a blank page here. This is an alternate method. The way to do it the alternative way. And if you want, do you want to just watch? I like this way. I'm going to do it in one step. D equals VIT plus 1/2 AT squared. I'm going to do it all in one step. What's the overall displacement? Correct. Negative 400. 2 today for you. What's the, do you want to go for 3? What's the initial vertical velocity? Okay? I just can't. No, you know it. Come on. Is it not? Now, plus or negative? It's positive because it's up. Right? It's up. Plus 1/2 of minus 9.8 t squared. Now, are you seeing ahead here? No? 1/2 of minus 9.8 is minus 4.9. We want to make that positive, so let's go to the, so we're going to take this negative 4.9, is going to go to the left, and it's going to become 4.9 t squared. And then the 8t is going to go to the other side, and it's going to become minus 8t, and the minus 400 is already there, and yes. I do like this. You know why I like it? It makes me feel smart. I'm smart enough that I can work this out. It's elegant. It's like, yes, I'm using my mathematical powers and I can do this. Yeah? Okay. Oh, it is ugly. So here's what I'm going to do because I'm such a nice guy. You all have smartphones. You all probably can come up with a quadratic formula solver. You can probably come up with a grapher thing like Desmos or something like that. Can you not? What's that, you say? Does he? Why don't you get it? What do you mean? It's awesome. Give me that formula. What was it? 4.9. Hang on. Okay, 4.9. We got to exchange the t for an x. X squared minus 8x minus 400? Oh, yeah. Yeah. Okay, so we are literally solving for the zeros, right? So it's right there. What's that x value? 9.886. I'll zoom in a bit here. You have this, you can get it on your phone. 9.888. Get Desmos! Yep. I'm gonna let you do it. Yes. Insanity. But you gotta show me this. I'm not. Have I ever lied to you? When? Was it 9.885?
9.8.
9,888. I'll leave it like that. Technically, I guess it's 9.89. I think that's pretty cool. That you can. Oh yeah, yeah. I just feel like I've got this like superpower that I can do it that way. Hannah disagrees. I can tell by the look on her face. Your choice. If you want to do it 3 steps, your choice.
Well, how are you going to give us 11 marks if we didn't even do that?
Oh, we're still got more to go. This is actually only worth 2. If you need to, yeah. I'm only about 5 minutes away here. It's up to you. Okay, what about the range? The range is what? How far it goes sideways. Does the horizontal velocity change? It does not. So, now again, you can do this or you can go either one of these, right? What is the horizontal? Was it 6? Yes. Right? Displacement solved for time, which was 9.89. $59.34. Or if you want, you can go d equals, what's the initial horizontal speed? 6. The time, 9.89 plus 1/2 of, oh, hang on, 0. Why is the acceleration 0? Because it's horizontal acceleration. That's the danger with doing it this way. Because it's really just going to be 6 times 9.89, isn't it? Now, if you're working for the military or something, rather you're trying to figure out, where is this thing going to land? I guess really they're working backwards. They know where it is, and they want to figure out what angle to launch it at. Ooh, that'd be a good test question.
No. Yeah. Ooh. It's the exact same thing.
Just backwards.
Wait, why did you? Oh, no.
You have to do it the right way. All you have to do is
You can't do that in my class.
the initial velocity.
You'd have to know either the muzzle velocity or the angle. I couldn't get you to figure out. I could ask for one possibility, but that would be pretty hard. That'd be impossible. Not impossible, but scrap that idea? Velocity to impact. How fast is it going at impact? Well, it's made up of that horizontal component and the vertical component. And the horizontal component remains constant, 6. So what is the vertical component? Well, it is the final velocity given an initial velocity and an acceleration at a certain time period. The initial was +8 up vertically, plus minus 9.8, and our time was at 9.89 value. I get minus 88.9. And if the horizontal is only 6, it's basically doing what? It's basically just going down, isn't it, right? Like it's going to be like little tiny 6 and then like great big down, right? It's going to be like almost straight down. Minus 88.9. But technically, I do have to find that hypotenuse, right? So this here is 88.9, so it's going to be v squared is equal to 6 squared plus 88.9 squared. Because I bought it from Mr. Strozak and I haven't taken it home yet. He's my supplier. That always gets a laugh when I say that. His son is an organic farmer and has like lots of different items, and I buy his honey. It's literally raw. It's unpasteurized. It's right out of the hive. Yeah. Do you want to be my supplier, Dan?
I work on people.
Oh, do you? 89.1. And why is that? Because the vertical is so high, right? So that's why it's hard to change it all. And do you need the angle? Yeah. It's going to be some really big value. Inverse tan of 88.9 all over 6. I get 86 degrees. And how do we describe that? Below the horizon. BTH. Or the Mitchell-Product way. Horizontal and then down. Now you may go.
What if it's above the horizontal? Can you write A?
ATH. In fact, good question. This, right? This 53 above the horizon, right? So is there 11 marks there? Let's just see.
Wait, that's it?
Yeah. Sure. We'll go through this here. So we got 1, 2, 3, 4. I guess that those are one and the same, right? We're at 4, 5, 6. That's the same one. 7. I'll come back, Nick. 8, 9, 10. I lied. Shelby, I've never lied to you.
Just did again.
So if you like write like 86 degrees, you forget the BTW.
Probably a half.